Welcome to video 5 on applications of vectors. In this video we're going to look at the dot product of vectors. The definition of the dot product says if you have a vector u with components a sub 1, b sub 1, and vector v with components a sub 2, b sub 2, they are both vectors, then their dot product is denoted by u dot v is equal to a sub 1 times a sub 2 plus b sub 1 times b sub 2. Note that the dot product is not a vector, it's a scalar. So you'll get a number when you calculate it. Let's look at example 6. We're asked to find the dot product for components 4, 2 dotted with 1, negative 3. So I'm going to rewrite this as 4 times 1 plus 2 times negative 3. Notice that I've not worried about the negative sign until the very end. 4 times 1 is 4, and 2 times negative 3 is negative 6. If we add 4 and negative 6, we get a negative 2. And that is my scalar. Notice we've converted to a different format for our vectors now. We have 6i vector plus 2 times the j unit vector dotted with I minus 4j. Now remember, these are unit vectors for I and j, so we are still looking at vectors, they're just written in a different format. So we could do this several different ways, but I'm going to convert these to component form first before I then worry about the next step. Since 6 times a unit vector in the x direction will give me 6, and 2 times a unit vector in the y direction will give me 2, I will have a component vector 6, 2 dotted with 1, negative 4. So that will give me 6 times 1 plus 2 times negative 4. Now if you think about this, we're looking at how far this vectors have gone as a product in the x direction and the y direction. Now 6 times 1 is 6. Plus 2 times negative 4 is negative 8. And so together, we have negative 2. I had an extra step in here because I had to convert my I and j vectors to component form before I found the dot product.